Welcome to my session on the evolution of consciousness. Now, in my talk, I want to talk about how we can develop an ethological science of consciousness. I'm very pleased to have been invited to this conference, which is the perfect place to give this talk. I'm a PhD student at the University of Sydney, working with Paul Griffiths and Peter Godfrey Smith and Marion Dawkins at Oxford, writing on how we can develop an evolutionary framework for the science of consciousness that moves animals towards the center rather than just keeping them at the periphery of discussions about human consciousness. So how can we develop an ethological science of consciousness? This is the question I want to address here, and I argue that we basically need an evolutionary framework. Now, John Maynard Smith once said that evolution of sex is the hardest problem in evolutionary biology, but I think it is more sensible to say that it is the evolution of consciousness, or how consciousness makes sense in a biological view of life. So he said, what consciousness is, we know not, and how it is that anything so remarkable as a state of consciousness comes about as a result of irritating nervous tissue is just as uncountable as the appearance of the jinn when I let interrupt his lamp in a story or as any other ultimate fact of nature. There's a very famous quote by Thomas Henry Huxley, famous for being Darwin's bulldog, and this influenced many scientists at the time. They could not see how we could explain it by the means that Darwin provided us with, but not everyone saw it like this. And now, even today, we are faced with a wild sweep of alternative, perhaps more so than ever. So in nature, we do see this striking difference between systems without any sort of conscious experience, like Australian bushfires, the plants that succumb to them, robots, bacteria, our planet, other stars, and the universe as a whole. Those systems like humans, for which there isn't something it is like to be them. This we see as a conscious state, a conscious being. Also, most take for granted, at least. When you ask whether something is like to be a bat or any other living organism for that matter, we're asking both whether they have subjective experiences of any kind and what these experiences consist in. Yet how could we possibly learn about the nature of this elusive phenomenon? And this has been very difficult. But now that we have journals like Animal Sentience and Animal Cognition publishes about animal consciousness, animal consciousness has been more and more gaining steam among animal behaviorists, animal cognition researchers, neuroscientists, and ethologists, funnily enough. And we can see this, of course, with all these books that have been published about animal consciousness. Donald Griffin, very prominent here for trying to establish a cognitive ethology in the 70s. He was very influential in driving research in animal cognition. We can thank him for breaking this taboo and studying animal consciousness. However, for a long time, cognition was researched without consciousness, and that's not something he wanted when he argued that we need a cognitive ethology. So how can we establish a cognitive ethology? Well, we need to think about what it's like to be these animals. And obviously this is what Nagel said. But what I mean here is to take an ethological viewpoint and think about the particular lifestyles and ecological evolutionary pressures that these animals experience during their normal lives. So there's two senses of the place of mind and nature. One is the relationship between matter and mind, and one is about the literal location of the place of mind and nature, which is the animals that are conscious, including us. And I argue that we can make sense of these two problems by thinking about them via evolution, putting them through an evolutionary framework. As Dobzhansky said, nothing in biology makes sense except in the light of evolution. And Simona Ginsberg in Nervilla Blanca in a recent book said that evolutionary theory is the most general framework for understanding the biological world. It's a conceptual bottleneck through which any theory of life and mind must pass. If a biological or psychological or sociological theory fails to pass through this bottleneck, it is likely there's something seriously wrong with it. And this is the approach ethologists take as well. Now, in my dissertation, I argue that we need to go back to Donald Bradfield Griffin when he said that most of Darwin's basic ideas about evolution are now generally accepted by scientists, but the notion that there has been evolutionary continuity with respect to conscious experiences is still strongly resisted. Overcoming this resistance may be the final crowning chapter of the Darwinian revolution. But how can we overcome this? Well, he himself said that when we think about animals, we have to think about what it's like to be them, and we can only do this by sort of taking their place. And this is very much what ethologists always argued, that if we want to understand biological organisms, we need to almost become them. Of course, Lawrence said it in a bit of a romanticist way, but there was a scientific reason behind it. Now, in my dissertation, I argue that we can make sense of consciousness by arguing that the function of consciousness is to enable the agent to respond to pathological complexity. And by pathological complexity, I mean the particular evolutionary pressures of a decision-making agent in a complex environment with a complex body, with different needs competing against each other, dealing with trade-offs. Now, this is similar to how Peter Godfrey Smith once argued about environmental complexity being related to the evolution of cognition, but that was concerned with both a different explanandum and a different explanans. Now, Konrad Lorenz famously once said that if you confine yourself to the Skinnerian technique, you study nothing but the learning apparatus, and you leave out everything that is different in octopi, crustacean, insects, and vertebrates. In other words, you leave out everything that makes a pigeon, a red a man, a red, a man, and above all, a healthy man, a healthy, and a sick man, a sick. So we need to emphasize here that he talked about health. And in my dissertation, I emphasize very much that pathological complexity is something you can only make sense of once you make sense of the biological normativity of the organism. And by this, I don't mean anything philosophically strange, but the right, straightforward, telenomic purpose of the organism. So Ruth Millikan, a famous philosopher, once said that living chunks of matter do not come just as such with instructions about what are allowable conditions of operation, what is to count as allowable input. Similarly, they do not come with instructions telling what is damage, breakdowns, or wear downs. Nor do they come with instructions about which processes are to count as occurring within and which are irrelevant or accidental to the system. Now, how to make sense of health as a natural phenomenon? Both Millikan and Lawrence made very similar remarks regarding how we should study it. We need to make sense of the telos of the organism. And that just means we have to make sense of the evolutionary pressures that led to their design. And the ethologists used famously ethograms to make sense of the particular lifestyles animals live. So the goal was to first study what animals do in the natural environments, what their lives are like, their normal lives, and such that we can distinguish the normal from the pathological, the healthy from the sick, and the usual behaviors from abnormal ones. And I'm sure everyone at this conference is familiar with this. Ethograms are still famously used in zoos. We can make sense of different behaviors. We can use them as indicators for welfare and their positive or negative mental states. So this is very useful. But now in behavioral ecology, we have developed more refined tools. We have a 21st century equivalent, and that's an entire theory, state-based behavioral and life history theory. Here, the goal is to make sense of consciousness, at least when you apply it to consciousness, in terms of the goal of the organism in that particular environment. What is a fitness maximizing agent trying to do with this particular body in this particular environment? And I argue that passing the problems of consciousness through this Darwinian bottleneck that ethologists created will transform the two problems I raised in the beginning, which animals are conscious and how is matter and mind related, into a single question: constrain what a biological theory of consciousness ought to look like, and provide us with rich theoretical resources to address the perhaps greatest challenge of biology. And the question is this: in order to develop a true biological science of consciousness, we must attend to the cognitive ethologist's demand to address the functionalist question of what consciousness in all of its diversity and gradations does for healthy agents within the normal ecological lifestyles and the natural environments they have evolved in. So this takes us far away from a paradigm in human consciousness science. So it's very much focuses much more on lab work and on humans, where consciousness might play a very different role from how it has originally evolved. Consciousness might have been transformed in radical ways. And as many Darwinians often argue, we need to think about the origins of so many phenomena in order to understand their function and operation. Watson famously argued against the pressures of his time that wanted to make all references in psychology in reference to human, that to make consciousness as the human being knows it, the center of reference of all behavior, forces us into a situation similar to that which existed in biology in Darwin's time. And I argue that the exact same thing applies now. Modern consciousness science suffers from the exact same flaw as its counterpart in the late 19th century. Now, the behaviorists, of course, took a different path. Their goal wasn't to put animal consciousness at the center instead, but rather to replace both and any references to consciousness. But there's a different path that we could take. Now, Dennett famously argued that the cognitive ethologists, such as Donald Griffith's goal to study the different minds of animals, he argued that couldn't be done in that way. And he said we could do so in a constructive, anchored way by first devising a theory that concentrated exclusively on human consciousness. He denied that we could start with the animals, but I think this is the problem. This is the same problem as the behaviorists first argued. The one variety about which we will prove no maybes or probablys. No, I think this is a mistaken approach. And instead, we need to follow Watson and realize that the moment zoology undertook the experimental study of evolution and the situation immediately changed, mean ceased to be at the center of reference. We need to do this in consciousness as well. As Lamarck argued, for the study of these two kinds of objects, matter and mind, apparently so distinct, has been initiated man himself. Now his organization, having reached the limits of complexity and perfection, exhibits the greatest complication in these causes of the phenomenon of life, feeling, function. It's consequently most difficult from which to infer the origins of these. Now, this is why I argue, in order to have an ethological study of consciousness, we need to remove man from the center of reference. And this is a useful lesson that we can, in fact, apply to the behaviorists. Now, this behaviorist zeitgeist, nevertheless, stopped the study of consciousness in many ways, and we need to think about what the ethologists distinguished them from the behaviorists at the time. Now, many argue that it's just lab versus field work, but that's not really the case. There's an underlying philosophical reason. And Konrad Lorenz beautifully argued here that what behaviorists exclude from the narrow circle of their interest is not only other learning processes, but simply everything that is not contained in the process of learning by reinforcement. This neglect remainder is neither more nor less than the whole of the remaining organism. What remains uninvestigated is all that makes an octopus, a pigeon, a rat, man, a man, as I said before. Now, here he beautifully emphasized that this simply could not work efficiently if we want to do science. Information could, of course, be gathered by the behaviorist method. It is exactly the way in which a species, by random mutation and recombination, gathers information and adapts itself to its environment. However, we also know that the very slow speed with which this procedure operates, and we prefer to have results before the present interglacial period comes to an end. That is why ethology empathetically keeps to well-tried Darwinian procedures. And now we have to do that with consciousness as well. And if you look at Animal Sentience Journal, I think this evolutionary consideration is still missing. An ethological approach is still missing. It's just an attempt to use the results from human consciousness science on animals. Now, my pathological complexity thesis is intended to overcome this bias. Seemingly we can, or we must start with humans because these are the only conscious experiences we know. But this is not how we can establish an ethological approach. Now, Dan Dennett once argued that the complexity of an autonomous, self-protecting, self-advancing, but mortal, vulnerable, and little machinery gives us an explanation of why it is equipped to suffer and why its suffering matters to it. And this is the approach we should take. And in my thesis, I argue that we can explain the phenomenological complexity of consciousness. There are a huge variety of different experiences that might very well differ in animals from us and different animals from other different animals. To make sense of this, not in the sense of an all or nothing quality as it often discussed, but and neither typologically discrete, but in a very different way, in a gradualist way with lots of varieties. Jonathan Birch, together with collaborators, has tried to develop a multidimensional framework for how to make sense of the different experiences of animals. I think that's a very useful approach. I'm not sure these dimensions are determinate. They might just be a very useful guide to get rid of unidimensional thinking. But they constitute progress in any way. And then we can think about which of these dimensions is primary. And I think if we follow the Darwinian and Darwin's pupils Romanes line of argument, we can think about pleasure and pain as the most basic states, as the most evolutionary ancient ones. And once we establish that at the bottom of consciousness, we can use this to make sense of consciousness. Now, this is supported in experimental philosophy. Normal humans seem to distinguish a conscious human via evaluation rather than mere sensation. So robot can sense a particular molecule, they would say that he does, but when it comes to evaluation, smelling a rose, something that is seemingly positively valenced, then it is denied often. Now, we can follow this by linking pathological complexity and phenomenological complexity such that we can develop a testable empirical framework that brings ecological and evolutionary thinking to the forefront. Now here similarly, Konrad Lorenz said that we need to think about the what for of different organs and ecological relations between the organism and its environment. And that's exactly what we have to do with consciousness if we want to take an ecological approach. I follow McFarland and Sibley. They argued we need a common currency, a value of evaluation in order to do efficient decisions, in order to deal with complex behaviors with multidimensional objects and outcome. Now, how can we use this to make sense of experiences of different animals? Well, if you think of slugs, they have very poor sensory capacities, but very rich evaluative ones. And now there are many debates regarding whether they are conscious. And me and others, I'm just a visitor at the Animal Sentience Lab at the LSE, are arguing that snails probably are conscious because they show these rich evaluative capacities. And bees not only have these rich evaluative capacities, but they also show very rich sensory capacities. And by trying to understand the evolutionary lives they live in their usual ordinary lives, I think we can make a lot of progress on this. Now, I didn't have the time to go into detail here of how we actually use pathological complexity to make predictions. But the way we do it is to construct these ethograms, to map out their life histories, and then try to make predictions regarding which conscious states they likely have, and then probe this via the experimental batteries that have been developed and try to test our predictions. And if our predictions fail, we might then reconstruct the pathological complexity we think these animals are faced with, such that we can have a useful empirical program that includes subjective experience as an essential element in doing ethology and in thinking about animals, and thinking about subjective experience as something that is important to animal life. So thank you for listening to my talk, and I hope you will find this interesting in making sense of different animals such as octopuses. Thanks for your attention.